Good day. My name is Chisom, and my group members are Esau Herrera and Ricardo Almagro. Today, I'd like to introduce our H-bridge circuit project and walk you through the specific components we'll be using. A H-bridge is a fundamental electronic circuit that allows us to control the flow of current through a DC motor. This ability to reverse current direction means that we can make motors run forward or backward with a simple push of a button. Our H-bridge implementation uses these specific components: four NPN transistors, which form the core of our H-bridge and create different current paths through the motor, allowing us to control its direction. Two diodes, which serve as protection components to prevent damage from voltage spikes when the motor's magnetic field collapses during switching. Two push buttons, which are our manual control interfaces. 22K resistors, which limits the current flowing from the transistor's base. 9-volt battery, which provides the power supply for both our control circuitry and the motor itself. The beauty of our design lies in its straightforward operation.
Okay, so how the circuit works is if I put this on battery and connect these two, this wire is ground, this one's alive. This one will go here. This one will go here. And you see that when I press this button, this diode will light up. When I press this one, this diode will light up. So since we weren't getting enough current, and because our transistors, we need a diode bridge to control the inductance of the motor, which we couldn't figure out in time in multisim, what we did was, instead, to show that this bridge is giving us an inverting voltage, we are creating an H-bridge. This H-bridge specifically has NPN transistors. Their model is 2N222A. And the way it works is that this button gets a voltage from here, and this voltage is going to cross through here and go through these two resistors, which will reduce the current so it doesn't fry the base pin, the base diode off it. And what that does is that it activates this bridge, this half of the bridge, which will connect through here, send a positive voltage through here into here. Then this positive voltage will go through here, through here, through here, through this wire to here, to this position. And this will be connected back to here, which will go through here. And this thing will be activated through the button being pressed. So it will go through here, and the final pin will go directly to ground. So when we press this button, it creates a finished connection. We can see it when we turn this diode on. And the other one is a mirror image of this one, which instead of doing that, we have these two base resistors, they're 22K. When we press this one, the voltage will go through here and activate these two transistors. And basically what happened here will be mirrored here, where a voltage will go through here, instead of going through the positive side that we said that this was positive, it'll go through the negative side, and then come out here, and then come back here and enter ground through this transistor. Through this one, which is facing this way. So when we press these two, this circuit will complete, but this one will stay open. And through here, this circuit will be complete, but this one will stay open, so none of them will be turned on. And when we press both of them, we'll see that one of them will flash. That is because the instant we press it, one of our fingers will start first and will hit the voltage first. But when we let go, we'll see that one of them turns on. The reason this doesn't turn on is because there's voltage going through both of them. So it will create a short circuit, which will, since there's two voltages going through it, the line, if we see in the multisim, the voltage will go through here. Instead of going through like these two positive nodes, they'll go through here, here, and here, and completely ignore through one of these diodes and directly to ground, which will completely ignore what we want it to do.
So as we can see on the circuit right here, with the battery, we have the two buttons right here. So since this one is closed, the voltage is gonna go from here all the way to this one. We open it, the current goes to 0, and so does the voltage. And then we open this one, close it, and it gives you negative current and it gives you the positive voltage, which is what the H bridge should be doing when it's working fine. And with that concludes our project. Thank you so much for watching.